Welcome to MyProjectBazaar.com. Now we discuss about the product for a parallel digital VLSI architecture for integrated support vector machine training and classification. Next we see the abstract for the product. In the area of big data, IT technology development and scientific research is becoming an increasing data incentive in recent years. For example, bioinformatics researchers often need to process tens of million points of data to be acquired in new insights of diseases and develop diagnostic and therapeutics. Processing such a large area can be take to huge amount of CPU unit times. Example for several weeks or even months also. That's another an example to address some of the key problems in asymmetric and cosmology secure kilometer area. The world quicker radio telescope located in Australia to be identify all the image and processing levels, extracting the pattern and classifying from the set of data and using them to interrupt and predict new data are usually achieved by applying machine learning and data mining technique. Support vector machine is a learning and classification algorithm has been successfully applied to a wide range of real world pattern recognition problem, and SVM learns by solving a constrained quadratic programming problem which whose size to equivalent to the number of training samples. The training phase of SVM is much more difficult to time consuming task than classification, and its implementation also more complex. Cloud computing provides a good solution for the big data processing, includes the training of SVM. At the same time, some parallel SVM algorithm can also be speed up the training phases. However, the software approaches are also based on the commercial general purpose of CPU instead of the declined application specific integrated circuits designed to optimize the particular for the SVM algorithm. Therefore, the hardware based acceleration has been done and explored in this work. This paper presents a parallel digital architecture for combined support vector machine training and classification system. For the first time, classify Cascade SVM powerful training algorithm they emerged to significantly improve the scalability of hardware-based SVM training and develop the efficient parallel VLSI architecture. This presents architecture achieves the excellent scalability and spreading the training workload of a given dataset over the multiple SVM processing unit with minimal communication overhead. Hardware-friendly implementation of Cascade algorithm to employ to achieve the low hardware overhead the following and allow to training over a dataset of variable size. In this proposed parallel Cascade training and classification system, its distributed memories are used to fully exploit the parallelism. In addition to proposed architecture, rather than the parallel processing of temporal reuse the processing resources, leading the good trades off between the throughput, silicon overhead, and the power dissipation also. Next we see the flow diagram for the product. First we select any one of the given images for the overall dataset, and to filter the selected input face image, and to using the median filter for filtering the image. Then to crop the face image only, and to resize the selected cropped image. Then to apply the Xilinx software. This process to be implemented in MATLAB 2013 year software process, and to apply the Xilinx software use the Xilinx 14.2 versions. This software to be read all the values from the text, and to apply the Xilinx based process. This Xilinx based process, first we process the feature extraction work. The feature extraction work we using the LBP local binary pattern feature extraction, and the DFT discrete Fourier transform feature extraction using the redundant based block multiplier. Then we use the feature then to identify the feature values for overall feature selected input cropped image and the database cropped images. Then to passing the Gaussian kernel unit. This Gaussian kernel unit is used to identify the kernel's points for the overall feature values, and to apply the Cordic based exponential processing element. This exponential processing element using the more number of rotating operations, because rotating operation consists of more circuit complexity, so we use the Cordic based approach for the selected exponential processing element, and we satisfy the exponential processing element function and to apply the scaling unit function. This scaling unit function to identify the overall database support vectors and the given selected test vectors, and to processing the all the process same about the overall database support vectors, and to apply the Xilinx software. Then to set the threshold value for the overall support vectors and the test vectors. Then the test vector and support vector is equal to minimum values of the condition to be yes or the no process to be analyzes the another section, yes process we identify the another next level, the matching data result to be selected, and to identify the face image for the selected face image, and to identify the person name for overall selected faces. This is the flow diagram for the overall process. Finally, we see the output for the product. We run the first main function to be selected the any one of the face image for overall dataset. So we select the any one of the face image. We select the one image, and to select the image and to be resize the image, then to be identify the face and to resize the exact face image only, and to apply the all the face image values to be write the any one of the text, and to directly open the Xilinx from the MATLAB, and to pass all the values to the text. For these all the values to be text, and to apply the Xilinx software. Then first we run the feature extraction process. So we use the feature extraction process LBP and DFT based feature extraction, local binary pattern based too, and the discrete Fourier transformation based feature extraction process to be identified using the code sequence. Then all the sequence to be analyze the face image value, and to identify the feature values, and to write the text, and to apply the MATLAB. We run the feature extraction process first, and to create the iSIM project navigator feature extraction identification process. After process simulated behavioral model success completed, then to open the iSIM project navigator automatically. Then all the files to be loaded and the text to be completed, process completed, okay. Then to close all the things. Then to close the Xilinx process and to select all the images. Then the feature extraction process is completed. Then we go to the classification process. Again we apply all the feature extraction values to the Xilinx software, and to run the classification SVM classification architecture for final, and to identify the person name for overall classification purpose. Then to run the SR RTL functions, this function to run all the values into the process. After completion successful, then to open the iSIM project navigator. This navigator to identify the what image to be selected. This navigator is to represent the person name. Initially null position to be presented for the person name, and we apply the clock and to identify the final person name for selected image. It's a loading of all the values into the text. Then to apply the 0 for initial clocking sequence. and to apply the clock is equal to 1, then to run, and finally we identify the selected face image. Finally we identify the Dhoni for the selected face image. These are the final process for parallel SVM architecture.